Would you like to get the chance to win a ROS developer's shirt and practice some ROS along the way? Then stay with me. This video is for you. Hello ROS developers, welcome to our channel and welcome to a new video of this series solving a ROS challenge of the week. In this case we are in episode 7, and for those who don't know it, the ROS challenge of the week is a challenge created by the construct where you are presented with a ROS-related problem that needs to be solved by you, and the fastest one to solve it will get a ROS developer's shirt like this one for free, just for showing off your ROS skills and for being the fastest one to solve this ROS problem, this ROS challenge. Yep. Then, as always, let's start getting our ROSject. Here we have it. So we are going to get a copy of the ROS challenge of the week number 7, as you can see here. And we are going to start open it. Meanwhile, I'll explain a couple of things. First of all, let's have a quick look here. So as you can see, this one, the number 7, the challenge 7, is an advanced level one, but actually it's not an advanced level. It would be more an intermediate level, but as I've already said, we are trying to start slow, so we are not making them very hard. But from now on, probably we are going to increase a little bit the level, especially in the advanced level one, to make it more advanced. But you will see now when we solve this one that it is pretty easy. So yeah, we are going to go for it and go to solve it right now. But before anything else, let me remember you a couple of things. First of all, here we have our Robotic Night Academy, where you are going to find many ROS courses, many interesting ROS courses, where you are going to get knowledge, all the knowledge base you need in order to solve all our ROS challenges, but also in order to work in your own ROS projects or for any company that needs ROS developers. And for instance, here we have the ROS Basics ones, ROS 2 as well, free courses for Linux and Python 3, and many other courses. Like for instance, in order to solve this challenge, the number 7, the most appropriate course would be the one for TFs, which I can't find right now, but it should be somewhere around here. Here we have it, TF ROS 101. So by doing this course, you will get all the necessary knowledge in order to solve this challenge number 7. So yeah, have a look and at the academy and see if there's any course that is interesting for you and go for it. So yeah, and also remember to subscribe to our channel, because besides this series, the Solving the ROS Challenge of the Week, which you can see here, we have many other ROS-related videos, super interesting, live classes as well, being held every Tuesday, and many ROS content, so stay tuned for all the new videos in this new year. By the way, let me say to all of you, Happy New Year. I hope you have a great year, this 2020. It's a nice number for a year, so yeah, let's hope everybody has a great year. And yeah, now let's go for the core of the video. So let's go to solve this challenge. And yeah, so the first thing would be to start the simulation. So let's come here to the instructions and let's see which launch file I need. So I need to select this ROSject of the week 7.launch file here in the simulations panel. Choose launch file and ROSject of the week 7.launch. Let's select this one, and this will start launching the simulation. And meanwhile it loads, let me open here an IDE where we are going to be able to visualize all our code, and also a shell, which I'm going to put somewhere here. All right. Then now we would continue with the notebook and check the problem to solve. So here it says, this ROSject contains one package inside the calculating workspace, which is called ROSject of the week 7_package. So let's come here to the calculating workspace, and here we have the package mentioned, here, the ROSject of the week 7 package, Excellent. This package contains some Python scripts and launch files for starting a TF broadcaster and a TF listener. The main purpose of these scripts is to make the iRobot follow the big turtle around the world. So if we come here, we are going to see that we have here a big turtle, and here we have an iRobot as here the notebook states. So basically the main goal of this is to make this iRobot follow this turtle. Yeah? So we are going to make this turtle move around the world, and this iRobot should be following this turtle wherever it goes. Yeah? Then, in order to make this work, first of all, let's source our workspace as it is indicated here in the notebook, and then we need to launch this command, which is going to start this iRobot follow turtle launch. So let's start this, and it says, at this point you should already see how the iRobot starts moving towards the turtle, like in the GIF below. So as you can see here, the iRobot starts moving towards the turtle, although the turtlebot is not yet moving, but we should see this happen here. So let's see what happens here. Okay, so apparently nothing is happened, and here we are seeing a kind of an error, which says, let me close this, by the way. It says retrieving model indexes, and then it says robot name iRobot is not in model state. Trying again. Okay, so here we have our first error of this challenge, so let's go for it. So I'm going to come here to the IDE and check the scripts. So as you can see here, we have two, the broadcaster and the listener. And basically here it's complaining about a robot name, which is iRobot. So let's have a look here. Let me do a quick search here for iRobot. I get no results. Okay. So let me come then here to the broadcaster and repeat again this search. And here I have a coincidence. So here I have iRobot. So this is how I would do it, but obviously you can solve it as you want. But yeah, so here with this error message, here I see that there is a robot name which is iRobot. So this must be set somewhere. So that's why I started searching here in the code for this word. And here I have a coincidence. Basically here we have this iRobot with turtle, which are being added to an array here, which is named robot name list. So let's have a quick look here at this code first of all. So basically you have two functions. One is handle turtle pose, and the other one is publisher of TF. This publisher of TF it's initiating a node here, then it's creating this robot name list array with iRobot and turtle. And then here it's it's creating here a gazebo model object with this list. And then here it's doing for robot name in robot name list so for each robot name, which are iRobot and turtle in this array, it's going to get the pose of that model. Yeah. So basically this should be, now I can say that this should be models. Yes, so models in gazebo, and with this function we are going to get the poses of these models. Yes, the iRobot and the turtle. Then here again we are doing another loop for each robot name in this robot name list. We are going to get the model pose, and if not pose now, so if we don't get the pose of the model, we are going to print this message, the pose is not yet ready, which by the way I think we already saw somewhere here, or not. No, not now. Okay, but anyways, so we are going to get the pose of each one of these robot names, iRobot and turtle. And if it's not ready, we are going to print a message saying that it's not ready yet. And if it is ready, so if we do have the pose, we are going to call this handle turtle pose function. Yes, passing the pose and the robot name associated to that pose. Then this handler turtle pose, we have it here. Basically what it's going to do, as you can see here, it's creating a transform broadcaster object here, and then we are going to send a transform for that model and its pose. As you can see here, we are sending the positions, the orientations, the time in ROSpy, then the robot name, so the name of the robot, in this case would be iRobot and turtle, and the frame. Yeah? Then the frame in this case. Okay, so let's keep going. Okay, so first of all, we have here the iRobot and the turtle. Yes? Then okay, what can I do here? First of all, what I need to know is the names of these robots. Yeah, in the gazebo simulation, both the turtle and the iRobot should have a name. And how can I know this? I can use, for instance, a service provided by Gazebo, which is named getWorldProperties, and this will give me the model names. If I call this service here, I have a list with the model names, and I can see the ground plane, which is basically the floor here, the ground. We have a Coke can, which is this Coke can we have here, which is not used for anything in this challenge. And then we have here two others, which are Turtle 2 and Turtle 1. Okay, so first of all, I can see here one thing. So there is no model named iRobot nor Turtle, yeah? The names are Turtle 2 and Turtle 1. We have also ground plane, but we know that this one is not the one we are interested in, and also Coke can, which we are not interested. So the model names we are interested in are Turtle 2 and Turtle 1. Yes? So the first thing I should do here is to modify this by Turtle 2 and Turtle 1. So now I have the proper ones. Yeah? Then another thing, here I have the frame associated to the transform. Yes? So in this case, this turtle frame, it's not representing nothing. So let me do one thing. So ROS run tf, oh sorry, I think it was like this, tf view frames. Yep. So this is going to give me a tf tree of this simulation, of this environment. Let's execute this in a PDF format. You'll see it right now. All right. Here we have it generated. So now I'm going to move these frames PDF here to the Catkin workspace so that I have it right here. It should be, yeah, here we have it. Now I'm going to download it to have a look at it. No TF data received. All right, so oh yeah, right, because there is no TF data being published yet. So so basically this is going to generate this new frame turtle, which is going to be referenced to the transforms both of the turtle and the iRobot. So better, I'm going to rename this. It's not necessary, but I'm going to do it because I think it's better to world, yeah, to have this common frame. So yeah, let's repeat again and let's try to execute the program one more time. So here we have the command. Let's see what happens this time if the iRobot starts following the big turtle. Let's see. All right. So nothing is happening again. Here we can see the message that we saw before. The robot model is not ready, turtle 2, turtle 1. And here we see that it's actually publishing the TF data. So now, if we come here and we do a ROS topic list, we can see here the TF topics, the TF and TF static, and we can even do a ROS topic echo of TF, and we will see here the message published. So here we have the transforms between world and turtle1 and between world and turtle2. Here we have them. So they are being generated properly, but this iRobot, which should be moving towards the turtle, is not moving. So let's have a quick look here to the TF listener. And basically here what we are doing is to generate a publisher, as we can see here. So we are getting here using the arguments. We are getting the follower model name and the model to be followed. Yeah. So the first argument will be the follower model, so the iRobot. Here, if we come here to this command, we can see here the first argument is turtle1 and the second argument is turtle2. Yeah. Then the follower is turtle1 and the followed is turtle2. Yes. So the follower here, it should be turtle1. So the turtle1 should be moved with the command vel topic. It's this true. Let's have a look. So let's come again here and let's do a ROS topic list and grep for command vel and let's see what happens here. Okay, so we have the command vel topic, in fact, but if we publish into the ROS, let me close this and let's do again this grep, and the command vel topic is no longer there. So it was there because we were creating the publisher, but actually it's not used for anything in Gazebo, yes, because otherwise it would keep staying here. So the ones that we have are turtle1 command vel and turtle2 command vel. So now we need to make sure to publish into the command vel topic related to the iRobot. So let's do one thing, ROS topic pub, let's publish into the turtle1 command vel topic and let's see what happens. So let's, for instance, make it rotate here real quick. And here we are publishing into the big turtle, so this is not the one we are interested in, so let's stop it. But we know now that our topic, the topic we are looking for, is turtle2 command vel. Yeah, so we need to add this here to the program. Let's add it here, turtle2 command vel. There we go. And then here we are going to basically, yeah, so we generate the message here for the shoot down hook, which will be to stop the robot basically. And then here we are doing all the calculations for the movement, so that, and generating as well the twist message here, linear, angular, depending on the position of the big turtle, which we are getting here from the transform. Yes. So, all right, let's save again this and let's repeat again our process. Let's run one more time our program. There we go. And let's see if it works. Hopefully it does, so that we don't need to get into that more complex issues. Okay, so we can see there the robot moving towards the turtle. Excellent, excellent. Okay, so this first part is working, and then the second one is to move around the turtle and see if the iRobot keeps following it. So that's what we are going to do right now. Let's come back here to the Gazebo simulation. There we have the iRobot, which is going towards the turtle. And now I'm going to start moving the turtle with this command, which I took from here, from the notebook, around the world. And let's see what happens. There we go, moving the turtle. And yeah, excellent. So we can see that the iRobot here, it's perfectly following the turtle wherever it goes. Yeah? Excellent. So yeah, basically you have solved this challenge. So as you have seen, it's pretty simple. So we could have made it much more harder, like modifying some things here. So that would be much more complex because you would need to have a much more deeper knowledge about this. But yeah, we decided to leave it like this for now. But remember that for further challenges, especially in the advanced ones, we are going to make them much more harder, yeah? So be prepared. Yeah, keep improving your ROS knowledge so that you are able to solve the hardest one as well. And yeah, this is all for this video. So as you have seen, we have solved this challenge pretty easily. So I hope you enjoyed the video, you've learned something new, and I will see you in the next challenge next week. So goodbye.